Hello.
Okay. Yeah? All right. So the way electronics are designed is normally using CAD tools where you have a schematic entry tool on one side where you define all your connections, and then you have a PCB layout tool where you then route those connections on a kind of physical model of your printed circuit board, and that's how electronics projects are designed. And if you once you do this, you can make a design that you can share with people, and that's what we call open hardware electronics, really. And that's been growing, really. There's a lot of I did this kind of survey last year at before FOSDEM, and I repeated it just now. And more people are sharing their projects online. So what this talk's going to be about is just going from a design that probably someone else has made and getting to the physical, working, assembled, printed circuit board. So electronics is kind of completely and utterly about making connections. And the only way to get better at it and at knowing what the right connections are is to try it out. And this is called a solderless breadboard. And with it, you can just kind of plug components in and see if it works. Maybe something will blow up, maybe not. But when you're getting started with this, I would look at this, what the inside of this breadboard looks like, because it's quite. If you're just looking at it from the outside, you don't know where the connections are being made. So take a look at this picture and see, and then you can realize where your connections are being made for you by the breadboard. If you want something more permanent, you'd probably use something like Proto or Vero or strip board. It's kind of the same names for pretty much the same thing. And there you can then solder on, and the components won't fall out anymore. As the designs get more complex, though, you probably want to have a printed circuit board, and you can still make this at home. You get a copper-clad fiberglass board, and there's a few methods of getting your design onto there. You can use a lithography process, or you can use what's called a toner transfer using an inkjet printer. But the important thing is to get the kind of ink onto this copper-clad board that's going to, when you then do the etching process, which is the next step, it's going to keep those connections there and get rid of all the other copper. So at the end, you're left with just the connections that you want. So if you're looking at an open source hardware project, though, you'll be looking for the Gerber files. And when you, most open source hardware electronics projects will have multiple layers. They'll have a solder resist layer and a mask layer, a silkscreen layer, and quite a lot of tiny drills that route connections between the different layers. So mostly you will want to use the industrial process for making printed circuit boards. So it's kind of, it is the same etching process in the end, but they have a few more extra steps and they have a lot more precision. So you can get a nice silk screen or ident layer which identifies, well, if the design is well done, it will show you where all the components are supposed to go and what the name of the project is. You have a much more accurate drilling, and the drills themselves are internally electroplated so that connections can be made between layers. And you can have a lot more different layers. They laminate layers together. You can really do up to 16 or even 32 layers, though that's quite expensive. But on the whole, this is really cheap, and there's loads of services that will do this, gladly do this for you. And it doesn't take too long either. It'll take about 2 weeks to get your printed circuit board manufactured. If you pay more, it'll be quicker. But obviously, the printed circuit board is only part of the puzzle, and we also need to know what components we want. So when you're looking at an open source hardware project, we'll look for the bill of materials. So this is normally a spreadsheet that defines exactly what components you want to buy. I actually have an open source project, which is a browser extension that helps you get from this bill of materials to the browser shopping cart. Obviously, you can do this manually as well, but this is my project, which this animation was supposed to start somewhere else, so it's going to just take a little bit longer. But Anyway, so in the end, it's supposed to go into the shopping cart, and you can watch this on the website itself. I went even further with this and made a kitspace.org, which is a platform where people can upload complete designs, and they put their Gerber files on there and their bill of materials, and you can easily get all the parts you need to replicate a project. But let's talk a bit about the components. These are resistors. That's what they look like. You can have through-hole or surface mount. There's no scale for this, but this component is tiny. I don't know, it may be a mistake to make it so huge on the slides here. So surface mount just means that you don't have legs, and when on the printed circuit board, it sits on top, and it doesn't go through the holes when you solder it. The capacitors come in all kinds of shapes, really. The bigger electrolytics, they're normally polarized, so you have to watch out which way around you have those. But they come in tiny surface mount versions as well. It just depends on what kind of values you're looking for. Inductors are really just coils of wires, often wrapped around a ferrite core, and they have very interesting electromagnetic properties. They come in surface mount as well. Diodes come in a lot of different shapes too, but most people will be familiar with our light-emitting diodes, also known as LEDs, and that's a great way to add lights to your project. Transistors are normally like 3-pinned black packages, sometimes 4 pins if they need to dissipate a lot of heat. And integrated circuits are normally rectangular packages with pins coming out. So now that our PCB, let's say our PCB has arrived, and we want to go from this bare PCB to the assembled board. The first step is to make sure your PCB stays in place. You can use blue tack for most jobs. The only problem with blue tack is that when you heat up the board, as the board gets hotter, it kind of melts away. But it does the job, and I use it a lot, actually. You might opt for something a bit better, like this kind of third-hand cracking tool that will hold everything in place. And obviously, there's even more professional tools if you're inclined to spend more money on your tools. So through-hole soldering, or any kind of soldering, really, the crux of it is that you want to get heat into the 2 bits of metal that you want to join. So you put your soldering iron onto the pin and the pad that's on the PCB, and then you add solder to both of those. What you want is a soldering iron in the station, not a soldering gun. Those are normally for plumbing or other kinds of metal work. I would stay away from these really cheap kind of stands where you just lean your soldering iron on there, because you'll probably burn yourself. On the whole, you're probably going to burn yourself, but these make it even more likely. The chisel tip is the most versatile tip, really, because as I said, for soldering, it's all about trying to get heat into the bits that you want to solder. So the bigger area on the chisel tip makes that easier. Pointed tip does have its place for really kind of fine bits, but really I would recommend you start off with a chisel tip and use it until you run into problems with it. So you heat the pad, you add the solder, you continue heating for a few seconds, and you let it cool down. And as you practice this more and more, you'll be able to see when it doesn't look so good. You will be able to see from the site. You can have too much solder or not enough, or a cold joint where it's just attached to the pin really rather than the pad, or you've burnt it, held it on there too long and it's burnt it, or you have shorts in your circuit where things are being bridged. I think one of the tips when I was starting out that helped me the most was just to try and relax and get in a really comfortable position and do your soldering that way. And makes it a lot easier to hold your hand steady. Just try and take all the weight off your body and that helps a lot. I would also say don't be afraid of surface mount soldering. You can easily do surface mount soldering by hand. You can, I'm missing a slide, but okay. You can do it on protoboard, or you can bigger pitched components like this one in the animation there. You can easily do that by hand. It's all about the size, really. And for me, like once it gets below 0603 imperial, I move away from using an iron and use a different process. And if you have packages like this chip here, which has it has no leads really. It's called a quad flat, no leads. So then you probably don't want to use a soldering iron for that. And the alternative is to use solder paste, and you can hand apply solder paste, or you can use a stencil, which you can get from a lot of the PCB batching services as well. And you apply the solder paste, and then you place your components, and you can probably still do this by hand, unless you're doing a lot of boards. And then you can use something like a hacked toaster oven to heat the whole thing up, and hopefully everything will sort itself out. The solder, when you see in the animation there, the solder has a lot of surface tension, so it will, like if your placement isn't totally correct, it will kind of pull it into the right place often. I had a slide in here about the kinds of solder, which I'm missing, so I think I used the last version of my talk. I know. Hold on. Well, I'm going to run out of time if I do this faffing around, but there were a few projects that I wanted to show, just to kind of inspire you to try and get started. Let me try this. Well, I think I've run out of time, and I won't be able to show you those slides. This has gone out of sync. Ooh, disaster at the end. Yeah. Well, I just wanted to say you can learn more at your local hackspace. There's a lot of them around. They'll probably have a modified toaster oven, and yeah, that's all. If you like hardware, check out kitspace.org. There's a lot of projects that I wanted to show you some cool projects, and you just check that out and maybe try and make some of those. I've got a kind of curated list of resources as well if you're trying to get into electronics. There's the Open CAD and Open Hardware Dev Room. So if you're into electronics, come to that in 15 minutes really start, and I'll be giving another talk about using programming languages to do electronic designs, and there's some new cool CAD tools coming out. So that's all.
Okay, thank you very much. Are there any people that have questions?